ETL versus LT, the backbone of data processing for machine learning and AI. Hello, and welcome to this video. Today, we're diving deep into two essential data processing techniques that form the backbone of data science, machine learning, and artificial intelligence, ETL and ELT. We'll explore what they are, their differences, how they're used in modern data workflows, and the tools involved. Let's get started. First, let's break down what ETL and ELT actually stand for. ETL stands for extract, transform, load. Extraction involves collecting data from various sources. Transformation involves modifying the data into a usable format. Loading is the process of storing this transformed data into a target data system, like a database or data warehouse. On the other hand, ELT stands for extract, load, transform. In ELT, data is first extracted and loaded into a target system, and only then transformed within the storage environment. Now let's get into the key difference. ETL transforms the data before loading it into the data warehouse. ELT transforms the data after it's already loaded into the warehouse. But why do ETL and ELT matter so much in the world of machine learning, data science, and artificial intelligence? In machine learning and data analysis, we often deal with massive data sets from various sources such as databases, APIs, and data lakes. Before we can build a model or perform analysis, we need to extract the data from these different systems, transform it to clean, normalize, and structure it, load it into a platform where we can perform analysis. In traditional ETL, the transformation happens outside of the target system, which may be better for environments where the data needs to be cleaned and standardized before storage. However, ELT is more suited for modern data systems with powerful data warehouses that can handle transformation at scale, such as cloud platforms. Let's talk about the tools involved in each stage of ETL, starting with extraction. Extraction tools. Apache NiFi. Used to automate the extraction process from various sources, it integrates well with IoT devices and databases. Talend. An open-source tool that simplifies data extraction from APIs, databases, and flat files. Fivetran. This tool automatically extracts data from multiple data sources and integrates it with the target system. Transformation tools, Apache Spark, a powerful data processing engine that can handle large-scale transformations. DataStage, an IBM tool commonly used for transforming structured and unstructured data. dbt or data build tool. A modern transformation tool popular with data engineers that helps transform data directly in the data warehouse. Loading tools. Snowflake, a popular cloud data warehouse used for loading and storing processed data. Amazon Redshift, a highly scalable data warehouse designed to handle large-scale data loading operations. Google BigQuery, a serverless, highly scalable data warehouse that supports real-time data loading and queries. Now let's shift to ELT. Since the data is loaded before transformation, the process depends more heavily on the capabilities of the target system. Extraction tools. The extraction phase remains similar to ETL, so tools like Apache NiFi and Fivetran are still highly useful for ELT processes. Loading tools, Snowflake, BigQuery, and Azure Synapse are popular choices here as they can handle raw data being loaded quickly and efficiently. Transformation tools. In ELT, the transformation happens inside the data warehouse itself. Tools like SQL, often SQL queries are used to transform the data directly in the warehouse. Apache Spark. If your data warehouse can integrate with Spark, it's a fantastic option for large-scale data transformation. dbt. As mentioned earlier, dbt excels in transforming data in modern ELT pipelines by utilizing the power of the cloud. Now, what's the roadmap for ETL and ELT, and how do you choose between the two? ETL has been the go-to choice for traditional data processing systems, especially when dealing with structured data that needs to be cleaned and standardized up front. It's ideal when your transformation logic is complex and you need to ensure data quality before it reaches the target system. However, ELT is becoming the preferred approach in modern cloud environments. Cloud-based data warehouses like Snowflake and BigQuery can handle massive amounts of data, so it makes sense to load raw data first and then perform transformations inside these powerful systems. ELT is also better for unstructured or semi-structured data where you may need to explore and transform data iteratively. Key differences. Performance. ELT leverages the power of cloud data warehouses, offering greater scalability for large data sets. Flexibility ETL requires strict transformation rules before loading, while ELT offers more flexibility since transformations can happen later. Cost ELT can be more cost-effective because it reduces the need for powerful external processing engines, leveraging the computational power of the cloud instead. So, what does the future hold for ETL and ELT, especially as data science, AI, and machine learning continue to grow? We're seeing a shift toward ELT as businesses migrate to the cloud and deal with more diverse data sources. ELT's flexibility, scalability, and ability to handle real-time data streams are making it a dominant approach in modern data engineering pipelines. However, ETL is still relevant for industries where data quality is critical before storage, such as healthcare, finance, and manufacturing. ETL's approach ensures clean and structured data flows into the system, which is essential in highly regulated environments. In summary, both ETL and ELT are crucial data processing frameworks with distinct use cases. ETL transforms data before loading, making it ideal for complex transformations and data quality needs. ELT, on the other hand, takes advantage of the power of cloud storage to handle large-scale transformations after loading. If you're working in machine learning, AI, or data science, knowing when to use ETL versus ELT will greatly impact the efficiency of your data workflows. Which method is right for you depends on the tools you're using and the type of data you're handling. If you found this video helpful, don't forget to like and subscribe to stay updated on all things data science, machine learning, and AI. See you in the next one.